Not again! Piece of shit!
Before I start this video, I do a tiny commercial. I hope you don't mind. The one and only Flap Earth shirts. Available with long sleeves and short sleeves. The shirts have a special opening called a flap. That's for vaccinations on the go. Even the shirts with the short sleeve have this handy flap. And those are specially designed for the ball earthers. I hope you guys going to buy one because I need money. And you can find the Teespring link in the description box. If I was you, I will order one now because they are almost sold out. Okay, I hope you like this commercial. Bye.
Because we know the earth is flat. The earth really is flat. Flat earthers, we will be round. Earthers, the earth really is flat. We will be round. Earthers, flat.
Feel free to join me on Telegram. You can find the link in the description box.
We copy you down, Eagle.
Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
He lines the sextant up with the star. Sextant, position, the brains of the Apollo guidance and navigation system. The navigator can then determine the altitude of the orbit and the position of the spacecraft, just as he did around Earth, using a star and a lunar landmark in the command module sextant, position, the brains of the Apollo guidance and navigation system. Sextant, position. He lines the sextant up with the star. The navigator can then determine the altitude of the orbit and the position of the spacecraft, just as he did around Earth, using a star and a lunar landmark in the command module sextant, position. He lines the sextant up, position with the star.
Touchdown confirmed. We're seeing
Wow! Holy fuck! I can't believe my eyes! Apollo 17 landing on the moon? Did I miss this in 1972? Damn! Oh, I'm so happy. Oh, let me see.
Ignition detected. We copy you down, Eagle.
Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
I'm being followed by a moon landing. We've been up in on the moon landing.
I believe they're setting up the flag now.
Ow. Who the fuck did that? You taste like shit. Piece of shit.
Mommy.
Projector Rogers enabled.
To find his position in space, the navigator goes through the same kind of routine he used in orbit around the Earth of the spacecraft. The astronaut navigator finds a known star in the wide-angle telescope. He takes a sextant sighting on a known star and on Earth's horizon. In Earth orbit, they can use their sextant. An astronaut lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine. The computer, given this information, tells him where he is relative to the Earth. As the spacecraft approaches the moon, the same procedure, this time using the lunar horizon, tells him how close he is and his position in space. Once he has the star in position in the telescope, he moves the optical sextant. He lines the sextant up with the star and makes a reading. He must repeat the process with another known star so that he has two readings to give to the onboard computer. From this information, the computer determines the attitude, the brains of the Apollo guidance and navigation system. This system makes it possible for the astronauts at any point in their lunar mission to pinpoint their position. In Earth orbit, they can use their sextant. An astronaut lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine.
Jeez, that's a lot of coordinates. Are those space coordinates? Today we are going to check some moon directions and put them into a 3D model. Here on the prime meridian, on April 1st at 6:24, exactly at the opposite side, 12 hours later, so that's 18:24 p.m. (90° north) on the North Pole at 6:24 again, because that's the same time on the prime meridian on the equator. Let's start at the prime meridian at the equator at 6:24. We can see this part of this constellation called Fishes, and we can see it's in the same line with the sun and the moon pointing in this direction, and we can model this up on a globe. It had an azimuth of 88.6 and an altitude of 2.97. And this was the prime meridian on the equator. Let's do another one. Exactly at the opposite side, 180 degrees east. Here we are, opposite direction of the prime meridian, 180 longitude east. We cannot see this line here because it's below the horizon. This has an altitude of minus 4.62 and an azimuth of 271.4 west. Here is the line. These lines are 400,000 meters according to the program. And this globe is 200 meters in diameter. Let me change view. Now let's move to the prime meridian again, to the North Pole. Here we are on the North Pole at the prime meridian. Let's draw this line on the North Pole. This is at an azimuth of 93.68 and an altitude of 0.87. I will change view. Not really in line. They triangulate close to Earth. And this one not even triangulate. Maybe we need to draw another line from the South Pole. The South Pole on the prime meridian. Where is the moon? Ah, here. And it have an azimuth of 275 west. West? No. That must be east. Because you are on the prime meridian. So 275 west. Let's put that into a model. Prime meridian. We all know this is east and this is west. Here is the line. In a different direction. Almost 180 degrees opposite direction. Maybe we need to check the moon from the other side and approach the South Pole from the 180 longitude. Here we are. On the opposite side, on 180 longitude east. And as we can see, this points to the west, and it have an azimuth of 280. Here we are on the opposite side, 180 degrees longitude east. Here we can see that other line from the prime meridian at the South Pole. So the azimuth for this location was 280 degrees west. Almost 281. The protractor is still from the other line. And here we have the line 280 degrees west, measured from this location. These lines become wider or triangulate very close to Earth, and on top of that we have some problem at the South Pole. with the moon, and of course also with the sun, because that was also in the direction of that constellation. So we have this moon at the South Pole, at the prime meridian, with an azimuth of 275.49 west. And when we approach the South Pole from the 180 degrees longitude east, we have also a moon, a sun, and the same constellations in a different direction, west. That's the opposite direction, of course, when you move 180 degrees opposite to a globe. Oh, look here, the sun in front of the moon. This should be an eclipse. No, no report of eclipses here. Idiots. Oh shit, wrong direction. Maybe some retard idiot baller can repeat this and take his tiny model and draw some lines. Piece of shit. How do we navigate to the moon from space? It's everywhere. Retard clowns with your fake shit, idiots. Wow, holy fuck, Muhammad Ali. Don't tell me you went to space.
No, piece of shit. This is my gym.
You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Holy shit. Now you have a problem.
Okay, Houston, we've had a problem here. Houston, we've had a problem.
No, they can't hear you because you had an EMP, electromagnetic pulse from the sun. Go get your flashlight, Buzz. You know where it is? And now you have to look for your manual to operate the computer. Where is it? Can you find it? Holy shit. What was that? Holy! That's a turd. They had a tiny accident. Oh, idiot! You lost it. Where is it? Oh, huh? Oh no. That's Buzz. Taking a shit during an emergency situation. Look at him float like this turd. Keep him into the light, idiot. Damn. You did it again, idiot. Where is Buzz?
Because we know the earth is flat. The earth really is flat. We will be round, earthers, flat earthers, flat earthers.
I'm going to send timeanddate.com an email and ask why we see the moon in a different direction. And I choose the date of 20 July 1969, when those guys are still on the moon. Here, North Pole, 90 degrees north on the equator. On the 20th at 12 o'clock, the moon have a direction of west-northwest. And now 90 degrees south. On the 20th at 12 o'clock, 55 northeast. That is the opposite direction. (300 west northwest), 55 northeast. I will send him an email and see what this timeanddate.com got to say. Okay, let's see what timeanddate.com have to say about this. Hello Peter, thank you for your email. What's your question? Thanks for using our website. What's my question? My question was pretty clear. Can you not follow directions? But never mind. Yeah, I was wondering if he had read my mail, or he read the words in my mail and he cannot find the question here. Well, clear up something. It's the same as a question. My question was why the moon points in a different direction at 12 o'clock on the North Pole and the South Pole at the same moment. You're sorry, you cannot provide me an answer. Yeah, I thought so. And here in Telegram I predicted the outcome, that they are not going to answer me because this is not a bug. Thanks for your answer.
All of the information presented on our Sun and Moon pages is based on algorithms and data from the United States Naval Observatory and NASA.
NASA and US Naval Observatory. Yeah, that must be good.
Is based on algorithms and data from the United States Naval Observatory and NASA, which we have optimized to efficiently calculate accurate Sun and Moon times. The algorithms have been tested countless times and are monitored periodically to ensure continued accuracy. The algorithms have been tested countless times and are monitored periodically to ensure continued accuracy.
So we have accuracy and NASA. And of course the US Naval Observatory, which is the same team as NASA. And when those guys came back from the moon, that was the 22nd, I want to know from which direction they came. Did they came from west? Or did they came from east-northeast? I think that is pretty important to know, because you cannot come from two sides at the same moment. Let's check the accuracy of NASA when they return from the moon. This moon is like 90% or something. It's taken on July 22nd. No exact time on it, so they're not so accurate. So this is taken on the 22nd with at least a 90% full moon. And this is NASA's official website, nasa.gov. Maybe we need to check the accuracy between NASA and timeanddate.com. Let's see, we are here on the equator on July 1969, and here it's 22nd July, and it's 7 days after new moon. So this is not what we see on that picture from NASA's official website. This moon is almost full. And here on Moon Calc on July the 22nd, 1969, it showed the same. The moon is like 50%. That is not what we see here. This is not really accuracy between Team NASA and Team timeanddate.com. Huh? Moon phase calendar 1969, July 22nd, 50%. And what about Apollo 13? Let's see here, Apollo Flight Journal. Large image of the moon taken during the early hours of trans-Earth coast. I would say 80% moon. April 1970. April 11th, the day of the launch, 5 days after new moon. April 11, 1970, the moon, 30%. This is not 30%. 1970 moon phase calendar. April 13 is the first quarter, and we talk about April 11, so it's not even first quarter. Waxing crescent, 30%.
Our Sun and Moon pages is based on algorithms and data from the United States Naval Observatory and NASA.
Oh yeah, the accuracy of NASA is outstanding.
The algorithms have been tested countless times and are monitored periodically to ensure continued accuracy.
This is what I call accuracy. According to the official data, these moon phases are way off. The moon on the left is not 50%, and the moon on the right is not 30%. Apollo 16, near full moon, taken on April 16, 1972. Here is the photo in NASA's archive. April 16, 1972. Maybe we need to check timeanddate.com. April 1972. The 16th. That's 3 days after new moon. New moon. 3 days. Mooncock. April 16, 1972. The moon. 12%. 1972 moon phase calendar. April. 3 days after new moon. This is a big problem. This data should match NASA's images. And they don't. I'm digging in this data for years and I not come across a big shift. Can somebody explain this to me? We are here on July 17, 1969. This is just a couple of hours before those idiots land on the moon. I have 2 locations selected on the prime meridian. This is the equator and this is the 50 latitude north. This is +1 hour. This is 0 hour UTC. So we add 1 hour here, of course. So this is the same moment for both locations. And here the moon have an azimuth of 294.05. Let's move to the prime meridian. The azimuth was 294.05 and the altitude was 53.82. 53.82, 10, 20, 30, 40, 50 and the rest. Okay, this is one line. Let's move up. Here we are. The moon has an azimuth of 228.59 and an altitude of 44.14. Let's move up. The azimuth was 228.59. 228.59. And the altitude was 44.14. 10, 20, 30, 40, 44 and a little bit. Let's see where those lines are. Here we have, of course, this line from the South Pole at 180 longitude that points in a different direction. Let's see those 2 lines. Change camera angle. So look at those lines. Let me select the extended lines also. So those guys are going to land on the moon in about 4 hours. No way. The data show it's impossible. So place yourself on the North Pole and observing those guys landing on the moon. So how do I use my sextant on top of this globe? I want my mommy. Huh? Ah. Here on this app called Dove Moon, I selected the North Pole and the South Pole at the prime meridian, and it's the same date, same time. There is only like 2 seconds difference. I cannot select the date of the moon landings because my phone only goes to 2007, but that doesn't matter. All these apps use the data from the Nautical Almanac office, and we can see big differences in direction on the North and South Pole. So why we see this again? Because it's local data. It's not a global data. You cannot combine 2 celestial spheres from the North and the South Pole. You know, they should line perfectly up, but they don't. There is no way you can line these up, and you cannot stack them up, North and South, because then Zenith in the North will point to the North Star, Polaris, and in the South, Zenith will point to Polaris Australis. There is no way to combine those, and they are not made for that. Let's twist them around a bit and stack them up again. Let's see. North to North, South to South. No, it don't work. You cannot make a match. And that is because it's made for local use and not global use. Because if you use it globally, look what happened. Locally, you must use it. And if the sun and moon point in a different direction on those 2 locations, then we can bet the planets do that also. Take a look. No way you can line them up and make a point in one single direction from those 2 locations. Imagine I do 10 locations. It's impossible. This retard baller asked me for an accurate flat earth map. Do you have an accurate globe? Do you have a globe that can be used for long range navigation, like traveling to the moon? So in what direction you travel to the moon from the South Pole? And in which direction you travel to the moon from the North Pole? And I told you, angles become wider when you measure from 2 different locations. And you say they don't, but they clearly do. Moon landings can only happen when you're not upside down on a globe. What do you want now, idiot? You want me to model up the equinoxes on the North and the South Pole? Your orbital mechanics seems to be broken.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Maybe it's a good idea to do an astronomy course here at the University of Nebraska. Let's see what they have here. What is this? Switch. Ah, cool. Ah. I'm now at the bottom of the globe. On the 50 latitude. 60 latitude. See what happens if I do a switch. Oh. Ah. You see that? We turn ourselves straight up and create a flat level plane. Huh. What is this? Celestial sphere. Flat level plane. You see that? Flat and level. Oh, what do we have here? Flat level plane. Where is the globe? Oh, what is this? The moon and the sun position in the sky. Again, a flat level plane. And you cannot combine two of those celestial spheres. You must use it standalone. It's not made to use it globally. You must use it locally, like the data say. Oh wow. Again, flat and level. No globe. Oh, what's this? Meridian calculator. I don't see a globe. Do you? Ah, here. Another application that show a flat level plane for local use. What do we have here? Watch out, the blood is running to your head. Wherever I am, I'm straight up. It doesn't matter. I'm always straight and the sky is moving. The program is called Rotating Sky Explorer. Not Rotating Earth Explorer. Ah, here. Sidereal time and hour angle demonstrator. Yeah, looks flat again. And local. Ah, skyband simulator. I don't see a globe. Do you? Ah, what do we have here? Motions of the Sun simulator. Oh look, a flat map. Yeah, flat maps are handy. You need to navigate with flat maps, idiot. I don't see a globe. Ah, here, sunpad simulator. Animate. Yeah, this shows a local sun going over your head. Not a global sun. Sunpad simulator. Show poles. Let me see a pole. Oh look, his pole. But all those apps show how to use it locally and not globally. So, how do we explain it on the so-called flat Earth? like the data say. Locally. Do you understand that? All can have a 90 degrees east sunrise. This is what the data say. So tell me, what is wrong with this? All those locations see the sunrise about the same moment. There is a couple of minutes in between, or they are equal. It's different for each location. They all have a tiny different direction. But let's say they all see it at 6:24 a.m. like we can see here. 6:24. Everywhere an east sunrise. You see that? This is how it works. Or you're telling me the data sucks? As far as I know, all people see the sun at the correct times. Those sun-ups never lie. They speak the truth. Can some idiot tell me what is wrong with this data and use this data as it is? Here the sun on the 50 latitude north, 5th longitude east. The sun have an azimuth of almost 141 and the time is 9:43. I can use this data on any map with a coordinate system. 9:43, 20 minutes, 40 minutes, 43 minutes. And the latitude was 50 and the longitude was 5. The azimuth was almost 141. And that line don't represent distance, it represents direction. And you cannot make this line very long, because then everything is going to be messed up. So we place this celestial body right on top of the location, and then it still have the right direction and altitude. Nobody can determine how far celestial bodies are, and you cannot give a distance to it. Which of these moons is closer? And which moon is a 3D moon and which moon is a flat moon? You cannot tell by looking at it. All the presented sky models are wrong, because when you assign distances to those celestial bodies, then we run in all kinds of troubles, like I show in a ton of videos. Of course, you can make up any virtual distance and apply it to a model. I don't see a distance here. It's just direction and altitude. This is the direction of the sun for this location. And it doesn't matter if I model up 1 or 10 or 100 or 1000. You must do what the data say. And do you see somewhere they mention globe data? Or you want me to model up circling sun data that not even exist? So can you tell me what I did wrong? Okay, I will end this video with a little quiz. When you cross the 180-degree longitude from March 31, you have to add 24 hours. And when you cross the 180 longitude from April 1st, then you have to subtract 24 hours. Those two guys have an appointment on 180 longitude when the moon is overhead at noon. On the left side is April 1st, on the right side it's still March 31. Now my question to you guys is, at what date they will meet? If you know the answer, then write your answer in the comment section. Peace.
And a major key to this success is the Apollo guidance and navigation system, telling the astronauts where they are and how to get where they want to go.
How you like that, you fucking cocksucker?
That's all, folks.
Warp drive, Mr. Scott.
Piece of shit, stupid, retard. Piece of shit, stupid, retard. Piece of shit, stupid, retard. You're just an imbecile. You're just an imbecile. Piece of shit, stupid, retard. Piece of shit, stupid, retard. Piece of shit, stupid, retard. You're just an imbecile. Do you understand, retard? And some shit. Clown. Do you understand that? Clown. Do you understand that? Do you understand? Do you understand, retard? Stupid. Piece of shit. Retard. Stupid. Piece of shit. Retard. Stupid. Piece of shit. Retard. Stupid. Imbecile. Do you understand, retard? Piece of shit, clown. Piece of shit, fake ballad, fake ballad. You're a fake ballad. Moron. Fake ballad. Do you understand, retard? Fake ballad. Moron. Fake ballad. Do you understand? Do you understand? Piece of shit.
stupid. Fake bellen. You cannot be serious. You cannot be serious. Fake bellen. You cannot be serious. You cannot be serious. Imbecile. Imbecile. You cannot be serious. And some shit. And some shit. Fake bellen. Piece of shit. 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 Clown. Clown. Do you understand that? Do you understand, retard? Do you understand that? Do you understand, retard?